What's poppin', dogs? Mr. Allen here talking characteristics of exponential functions and their inverse is the wonderful logarithmic function. So we're going to be talking domain, range, asymptotes, intercepts, end behavior, and intervals of increasing and decreasing. So let's start with the exponential here. H of x equals 6 to the x plus 2, then minus 1 on the outside. I think it's helpful to do a rough sketch of this exponential so that we can properly answer the questions, all right? So my exponential sketch here, let's see here. Exponentials always have a horizontal asymptote of y equals 0 to start, but then if it shifted down, right, if it shifted down 1, now it's going to have y equals -1 for its horizontal asymptote. So let's do a little graph off to the side here. Myself, a nice little x and y axis here. 45, or sorry, 0 now. There we go. Okay, and if I'm going to graph that thing, we said we're going to have a horizontal asymptote at -1. So go ahead and plot that. And again, this is just a rough sketch, right? And then if I were to, I'm just going to think, like if I plugged in 0 for x, that'd be my y-intercept. I'm going to get 6 squared is 36 minus 1 is 31. So it's going to be way the heck up there. So somewhere way the heck up here. I'm not going to scale it, but it's going to look something like this. And this is enough to really answer the majority of the questions that we're going to talk about with the exponential function here, okay? There we go. We got that all in frame. Okay. So my domain here for h of x, we'll do all of h of x here in pink. So h of x will be in pink. My domain, that's going to be, I can go left, I can go right, all real numbers. Okay, so domain is all real numbers. Or you can go from -infinity to positive infinity. Those are the same thing, right? So all real numbers or -infinity to positive infinity means the same thing for our domain here, all right? How about my range? Well, my range, my function is always above, right, that y equals -1, which is my asymptote here, h of x. My asymptote is going to be y equals -1. My range is y is greater than -1, or you could write it as -1 to positive infinity. Cool? Either one of those, totally acceptable. Okay, lovely. Also, back to the domain real quick. If we weren't looking at the graph, are there any x values that I can't plug in to 6 raised to the x plus 2? I can have negative exponents, I can have positive exponents. There are no-nos when it comes to the inputs of this function. So anything goes for the x there, okay? How about my intercepts? Well, we actually just talked about this, right? If I plugged in 0 for x, I get 6 squared, which is 36. So I'd have, I'll even write this off to the side here. H of 0 equals 6 to the 0 plus 2. That's a 0 there. Minus 1, so that's going to be 36 minus 1 is 35. Did I say 32 earlier? I don't remember what I said. It's 35, though. 6 squared is 35. All right. So there we go. Got our intercepts. It looks like it also crosses the x-axis here. This is a little more intense to solve, but we'll tackle that when we get to the log, okay? We'll talk about that one here in a moment because that actually involves logs, and that's going to be our inverse, all right? Now, end behavior here, what's it doing as we go to -infinity? As x approaches, so we're talking about h of x here, as x approaches -infinity, my h of x is approaching, so h of x is approaching, it would be, looks like -1, right? It's approaching that horizontal asymptote. So h of x is approaching -1. And as x is approaching positive infinity, as it goes to the right side of the graph, at the h of x function, that function's going up, it's going to positive infinity. H of x is approaching positive infinity. Cool. There we go. And then intervals of increasing or decreasing. Honestly, these aren't very exciting when it comes to logs and exponents, because they're doing the same thing over the entire thing. Like for polynomials, it's like up, down, up. Oh my God, there's so much going on. Very exciting stuff here. For this one, it's just increasing the entire time. It's riding up that pink line there. It's increasing the entire time. So we will say here, increasing, and it's from -infinity to positive infinity. Cool? From left to right, it's just increasing the entire time. Yay, very exciting. So fun. Okay. So let's see here. We'll go light blue. We'll go light blue for the log here, okay? So for my log, or for my inverse here, I am going to rewrite it in log form. It is asking for the equation right up here, right? So I will go ahead and do that off to the side here. We've got, let's see, we'll have x equals And then it will be 6 to the y plus 2 minus 1. So now I need to resolve this for y. First step, first big picture step for finding an inverse is swap your x and y's. Then we need to resolve for y. First thing's an algebra 1 step, right? Add 1, I get x plus 1 equals 6 to the y plus 2. And then I need to loop it and a swoop it. That's the method I like to use. Gotta give credit to Thorndog, okay? Thorndog came up with that one, at least taught me anyways. I don't know who taught him. So log base 6, we start with the base, pass by the x plus 1, that's my argument of the log, equals y plus 2. Then I'm going to subtract 2, and we'll have log base 6 of x plus 1 as my argument, minus 2 on the outside equals y. So that's my inverse. We will write that in the inverse spot here. Log base 6, x plus 1, and then we got minus 2. Cool. Lovely. Notice that the log, the x plus 1, and the minus 2 are all in line with each other, and the 6 is lower. That's how it's supposed to be written. You don't want the 6 to be in line with the log, and then the x plus 1 look like an exponent. That's not right. No bueno. Okay. Excellent. Okay, let's see here. Now we are on to the inverse. All right. So first off, I could probably switch my x's and y's, right? So whatever that, let's see here, my y or my intercept right there was 0, 35. Now it's going to be 35, 0. So I'm going to have one over here, right? Let's see here. This other point is probably going to be somewhere down here, okay? And then that's meaning for that one right there. I'm just trying to like reflect it over that line, y equals x. And then what's my asymptote going to be? Well, if it's y equals -1 for the exponential, it should be x equals -1. So I'll plot that in, and that should give me a decent shape of this graph here. Again, it will answer the majority of the questions that I need to answer here without having a real lovely graph. I could plug this into my calculator. When you do plug logs in, you do get like it like cuts off at the asymptote and doesn't continue going down. Unfortunate, but a lot of them look that way. So it is helpful to know how to graph this thing by hand, okay? So boom, there we go. It's going to look something like that. I'm not exactly sure where that y-intercept is yet, but we can figure that out. And actually, let's go ahead and do that, okay? Wait, we don't even need a calculator for this. Check it out. Ready? If I want to figure out where this point is, okay, so we know accurately where to place things, okay, even though I already placed it, I could just plug in 0 for x, right? So in my inverse, which we have over here, we're going to do h inverse of 0, plug in 0 for x, equals log base 6 of 0 plus 1 minus 2. So we have log base 6 of 1 and then minus 2. So this right here, you can evaluate that without a calculator. I know I was reaching for it. I was reaching for the TI, but you don't need it. 6 to what power gives me 1? That's how you think about it to evaluate a logarithm. So 6 to what power gives me 1? 6 to the 0 power gives me 1. So 0 minus 2 is -2. Yes, that actually does work out really well. So 0, -2. Because it's below the pink horizontal asymptote, which was -1. Y equals -1. Beautiful. This actually all worked out really well. All right, cool, awesome. Well, let's go ahead and put that on our intercept here. We've got a 0, -2 for the y-intercept. My x-intercept is going to be, 35, 0. And then we can also get that the x-intercept for this one is -2, 0. Nice. I feel like I probably would have written them in, x-intercept first, then y-intercept, but whatever. It's clear as to which one it is because if it's 0, 35, it has to be my y-intercept because x is 0, and that's when it's crossing the y-axis, okay? Excellent, but I'll label them, okay? These are going to be my y-intercept, and this is the x-intercept. For both, right? For both there. Cool, wonderful, awesome. Let us continue here, filling all this stuff out. We kind of jumped ahead there. I got excited about my intercepts. I mean, what's not to like about intercepts? All right, domain, range, what do we got? Well, for domain, I'm always to the right of that vertical asymptote. So here we're going to be looking like x is greater than -1. Nice, and this is for h inverse of x, as is this line going to be, and down here. Cool. So then my range, well, my range keeps going down, keeps going up, so it's all real numbers, or you can go from negative infinity to positive infinity. Nice. Wonderful. We actually just had a discussion with Mr. Ernst about whether or not it should be y equals all real numbers or just all real numbers. And technically, it should not be y equals. I learned something today, all right? It should actually be this fancy thing it looks like is an element of that set, but you guys don't know what that fancy looking sort of E-looking thing is, so we'll just go with that, okay? All right. But then you have your interval notation as well. Negative infinity to positive infinity. Whoosh. Awesome. Okay. Asymptotes. We already said it is x equals -1. Took care of the intercepts. Awesome. We could skip that now. End behavior. So here's what's interesting with logs and end behavior. It doesn't go to negative infinity for this one, right? It gets infinitely close to -1, doesn't keep going. So when we write our end behavior here, we're going to have as x approaches -1 from the right-hand side, because we're coming from the positive direction, then h inverse of x is going to, it was going down, so negative infinity, right? So it was going down on this graph right over here. Hopefully you can see my pointer there. It was going down on this section. I'll just circle it, okay, as we got really close to -1 from the right-hand side. And then as x approaches infinity, h inverse of x is going to approach positive infinity because it is going up. Beautiful. One more thing. Intervals of increasing and decreasing. Well, what is the blue graph doing? From left to right, it's always going up, so it's increasing, but it's not increasing from negative infinity to positive infinity on this one. It is increasing from -1 to positive infinity, right? Because it never gets to -1. It gets infinitely close to it. That's just why we have it as a parenthesis, not a bracket. But then it does continue to go to the right, so to infinity. So it's increasing over that entire life of the graph, really, okay? So again, not very exciting for intervals of increasing and decreasing with these, but it is a question that can be asked, right? Those are multiple choice ones. You can be like, hey, which of the following is true about, log base 6 of x plus 1 minus 2 on the outside? And it might say it's increasing from negative infinity to positive infinity. I would select that one. It might say that the domain is all real numbers. I wouldn't select that one. But if it said the range was all real numbers, I would select that one, right? So those are the kind of questions we can ask. It's a multiple choice. All right, there we go, guys. That was a super dope problem. I know there's a lot going on with that thing. A lot of kids were overwhelmed with all the information on a review problem much like this one. But hopefully that helps you guys, and you enjoy all the fun exponential and logarithmic problems. It's exponentially fun, man. See you later.